In the periodic table, the chemical and physical properties of the elements vary in predictable ways within the period. The same pattern repeats from one period to the next. These repetitions are called the periodicity of properties. Among others, the atomic mass, radius, electronegativity, and ionization energy are periodic properties. The atomic mass represents the mass of an atom. Since the mass of electrons is negligible, only the mass of protons and neutrons is taken into account to find the atomic mass. The higher the atomic number, the more protons there are in the atom, and therefore there are more particles. In the periodic table, the atomic mass increases with the atomic number, from left to right and from top to bottom. According to the simplified atomic model, the atomic radius is the radius of the sphere that corresponds to the atom. Each time we move down a period, an electron shell is added to the atom. For example, hydrogen is in the first period and has only one electron shell. But francium is in the 7th period and has 7 electron shells. Therefore, an atom with more electron shells has a larger radius. In an atom, the positively charged protons and the negatively charged electrons attract each other. To simplify the drawing, we're not showing the neutrons. When moving from left to right within a period, the number of protons and electrons increases. The more positive charges there are in the nucleus, the stronger they attract the electrons. The electrons then move closer to the nucleus, and the radius decreases. For example, the neon atom has a smaller atomic radius than the lithium atom. In the periodic table, the atomic radius increases from left to right and from top to bottom. When two atoms form a chemical bond, they either share or transfer electrons. The nuclei of the two atoms tend to attract the bonding electrons towards each other, a bit like two people playing tug-of-war. This is because each nucleus with a positive charge attracts electrons with a negative charge. The force with which a nucleus attracts the electrons involved in a chemical bond is called electronegativity. Not all atoms have the same electronegativity. The more electronegativity an atom has, the more likely it is to attract or even pull electrons from another atom. Hence, the atom on the right, fluorine, is much more electronegative than the atom on the left, lithium. This is why it attracts the bonding electrons with a greater force. When moving to the right in a period, atoms have more and more protons in their nucleus. These protons therefore exert a greater force on the bonding electrons. Their electronegativity is greater. In contrast, when moving to the left, atoms have fewer and fewer protons in their nucleus. Therefore, these protons exert a weaker force on their bonding electrons. There, the electronegativity is smaller. However, this property does not apply to elements of the noble gas group. Since their last electron layer is complete, they are stable and do not generally seek to form bonds with other atoms. Their electronegativity is therefore 0. Going down within the same group, atoms have more and more electron shells. This means that the last electron shell is located further and further away from the nucleus. Therefore, the distance between the last electron shell and the nucleus is smaller for hydrogen than for francium. The francium nucleus therefore attracts less electrons involved in a chemical bond than hydrogen does. The electronegativity of francium is smaller than that of hydrogen. In the periodic table, the electronegativity increases from left to right and from bottom to top. The ionization energy is the energy required to remove an electron from an atom. A high ionization energy means that the electron is difficult to remove from the atom. If an atom is highly electronegative, it will have a high ionization energy. In other words, its nucleus attracts electrons very strongly, so that they are difficult to pull off the atom. But what about noble gases? Although they have no electronegativity, they still have an ionization energy because electrons can be stripped from them. In the periodic table, the ionization energy increases from left to right and from bottom to top, just like electronegativity. The elements in the periodic table are organized based on the periodicity of their properties. The atomic mass increases from left to right and from top to bottom. The atomic radius increases from right to left and from top to bottom. The ionization energy and the electronegativity increase from left to right and from bottom to top.